In Florida, many farms use stationary internal combustion engines that run on diesel fuel or electric engines to run large turbine pumps or smaller submersible pumps that draw water from the shallow or deep aquifers and deliver it to the irrigation system under pressure. Recently, there have been increased use of electric motors, which also coincides with high use of center pivot irrigation systems. Pumping plant efficiency is based on the combined effort of engine, motor efficiency, and pump efficiency ratings. In general, pumping plant efficiency using electric motors can average as high as 70%, while pumping plant efficiency of diesel engines can average as low as 25%. However, there are many management and maintenance variables that can affect these numbers. The most efficient pump can be selected to perform a given situation if three things are known. 1. Total dynamic head that the pump will be operated at. 2. Desired flow rate in gallons per minute. And 3. Suction lift. Total head is defined as the suction necessary to lift water to the soil surface plus the pressure needed to supply water throughout the irrigation system, as well as pressure loss caused by friction and elevation differences in the irrigation system. Suction lift is the distance from the water surface to the pump intake. A turbine pump has three main parts: the gear head, the pump bowl, and the discharge column. A shaft from the gear head to the pump bowl drives the impeller. The bowl is placed beneath the water surface and has a screen to keep coarse sand and gravel from entering the pump. There are also stationary guide vanes surrounding the impeller that provides a more uniform distribution of pressure. Submersible pumps are multi-stage vertical pumps connected directly to an electric motor that is designed to operate underwater. Some advantages of submersible pumps are maximum efficiency, can be used in wells at any depth, no priming is required, can be located at any distance from an electric source, and no possibility of air leaks. A right-angle gear is the most dependable and efficient method of transmitting power from an engine or motor to a turbine pump. Correct alignment is critical between the pump and the power unit, and the pump must also be correctly aligned in the well casing so that no part of the pump assembly touches the well casing. This is important because vibration in the pump assembly may damage the well casing. Finally, the pump, engine or motor, and fuel tank, if applicable, should be mounted on a firm foundation so that proper alignment points are maintained. A concrete foundation with a berm provides the most permanent and trouble-free installation. Since vertical turbine or submersible pumps are installed inside the well, there are definite capacity limitations for a given diameter of well casing. The maximum permissible speed depends on a number of factors, but for 4 to 8 inch wells, a speed of 3,600 RPMs is not uncommon. This speed is not advisable for larger pump sizes. The performance of a pump varies with the speed of rotation and diameter. The capacity or flow rate varies directly in relation to the change in speed, so that if the speed increases by 10%, the capacity increases by 10%. The head that the pump will develop, however, varies as the square of the ratio of the new speed to the old speed. Thus, an increase of 50% in speed means that the head developed will increase 2.25 times. Further, the horsepower required increases by the cube of the speed change. This means that an increase of 50% increases the horsepower requirement by 3.38 times. If the pump is driven by a constant speed motor, the pump turns at the same speed unless connected to the pump by drive belt pulleys of different sizes or a speed-changing gearhead. These arrangements provide different fixed speeds and not variable speed. When a pump is driven by an internal combustion engine, it is possible to vary the speed of the operation within the speed range of the engine. Also, the horsepower capacity of an engine varies when the RPM of the engine is changed. Regardless of the power source, pumping costs are an item that producers have some degree of control over. Pumping costs are often higher than they need be for two reasons. 1, more water is pumped than is necessary, and 2, the pumping plant itself operates inefficiently.